Hey guys, today we're going to talk about indeterminate forms and L'Hopital's rule. Okay, so indeterminate forms. So we talked about this before. Remember, it's when we're doing limits and we get a situation where 0 is divided by 0, or infinity is divided by infinity, or negative infinity is divided by negative infinity, or any combination of those. Okay, those are indeterminate because they don't guarantee that a limit exists. And if there is a limit, they don't tell you what it is. So you have to find some other way of determining what the limit is. So we did have some techniques for that. So we did stuff like this. Like the limit is x goes to -1 of 2x squared minus 2 over x plus 1. So if I just try to substitute -1 in here, I get 0 on the bottom, and I get 2 minus 2, which is 0 on the top. So that's an indeterminate form. So we did something like this. We just said, okay, you know what? I could take this 2x squared minus 2, and I could factor out 2. That'd give me x squared minus 1. And then that will factor to 2 times x plus 1, x minus 1. So I can change the top of this thing to be this, and then, oh, look what happens. The x plus 1 cancels the x plus 1, and I end up with 2 times x minus 1 right here. And that I can take -1 and plug it in, and I get -2 right here times 2, which comes out to be -4. And so I can figure out the limit. Or I had another situation where we could do something like this. Okay, what if I put infinity? What if I want the limit of this as x goes to infinity? So if I get close to infinity here, this goes to infinity and this goes to infinity. So this ends up being infinity over infinity, and that's indeterminate. Okay, but what I could do is I could say, hey, I'm going to divide the top and the bottom of this thing by x squared. So remember, if I divide the top and bottom of something, of a fraction, by the same number, I just end up with the same value I started with, right? So what happens when I do this? Well, 3x squared divided by x squared is just 3 minus 1 over x squared. And then this is, the x squareds cancel, and I get 2 plus 1 over x squared. So it becomes this. Now, if I think about this as x goes to infinity, well, then this goes to 0, this goes to 0, and I end up with 3 over 2. Boom. There's my limit. Okay? Piece of cake. Now, here's what L'Hopital's rule does. You can read all this stuff, but basically this is what it says. If you get an indeterminate form, when you're taking the limit as x goes to c of f of x over g of x, you can change this to the limit as x goes to c of the derivative of f over the derivative of g of x. And it's the same limit. Okay? So if you got a situation where, okay, I can't do this and I can't do this, try taking the derivative of the top and the bottom and then finding the limit of that. And if that doesn't work, take the derivative of those. Take a second derivative and see if that works. So here we've got find the limit as x goes to 0 of e to the 2x minus 1 over x. Okay, so if I do that, if I just try to substitute 0 in, here's what I get. Is I get e to the 0, which is 1, minus 1, which is 0, and then I get 0 on the bottom. So it's indeterminate form. All right, so let's try taking the derivatives, okay? So we'll change this to the limit as x goes to 0. Now, what's the derivative of e to the 2x minus 1? Well, that's e to the 2x times the derivative of 2x, which is 2, and minus the derivative of 1, which is 0, and the derivative of x is just 1. Okay, I can substitute 0 into this. That's going to give me e to the 2 times 0 is just going to be 1. 1 times 2 is 2 divided by 1. This is going to end up being 2. So that was a pretty easy way to find the limit of that thing. Okay. Now, this is one where if I try to find the limit as x goes to infinity of the natural log of x over x, as I go to infinity, this goes to infinity, and this goes to infinity, although it takes a long time. Okay, so I've got an indeterminate form. All right, so we're going to take the derivative of the top. So this will equal the limit as x goes to infinity. The derivative of natural log of x is 1 over x. And the derivative of x is just 1. So this is the limit as x goes to infinity of 1 over x. Okay, well that I can do. As x goes to infinity, this gets really big, which makes this fraction really small, which means that this goes to 0. And so that's that one's done pretty easily. Okay, what if I have to do it more than once? All right, here's a situation where, again, this is not real hard. Okay, as x goes to negative infinity, so this would be positive infinity on top, and this would be positive infinity on the bottom. So I can't, it's an indeterminate form. Okay, always assume, or always check it. Don't just assume it's an indeterminate form. So if I take the derivative, this is going to equal the limit as x goes to negative infinity of 2x. And then this is going to be e to the negative x times negative 1. Okay, so again, this is going to be negative infinity, and this is going to be negative infinity. So that's a problem. So what if I do it a second time? What happens? Okay, the derivative of 2x is just 2. And this is e to the negative x times negative 1 again, but that cancels that negative 1, so that's just e to the negative x. Okay, now this stays 2 as x goes to negative infinity. This goes to e to the infinity power, which is infinity. Guess what? That shrinks to 0 again. So that wasn't hard. I just had to do it twice. Okay, on this one, if I try to substitute infinity, I get 0, because remember, this is 1 over e to the x, right? And so this would shrink to 0, and that would go to infinity. So this would end up being 0 times infinity. So let's see. Let's rewrite this as the limit as x goes to infinity of, we'll put the square root of x right here. Actually, let's call it x to the 1/2. So that's that right there. Okay, now if I take the derivative, because again, I can't do this. So let's take the derivative of the top. So that'd be 1/2 x to the negative 1/2. And the bottom would just be e to the x. Okay, now I got to do a little manipulation here, because this is going to go on the bottom because that's a negative power. So the only thing left on the top is going to be 1. The 2 is on the bottom, e to the x is on the bottom, and the square root of x is also on the bottom. Okay, now what happens as x goes to infinity? Well, this goes to infinity, that goes to infinity, this whole thing goes to infinity, so this thing has a limit of 0 because the numerator is just 1, and then the bottom goes to infinity, so that's going to be 1 divided by a huge number. Okay, what about this one? All right, this one's got an exponent in it, and that makes it a little bit more difficult. But we had a technique for this that we did a couple of units ago. So we're going to apply that this time. Now, if I look at this, make sure it's in indeterminate form. So if I try to go to infinity, this is going to go to 0, right? So this is just going to be 1 in here. And 1 to the infinity power is just 1. So I don't know if that's really a limit of 1 or what. Okay. But here's what we can do. We can set this equal to, we can say y is equal to the limit as x goes to infinity of 1 plus 1 over x to the x. Now, here's what we can do. We can take the natural log of both sides. Okay? So let's natural log both sides. Okay, now why in the, well, here's the x right there. Why would I want to do that? Okay. First thing I'm going to do is I can move the natural log inside the limit. And remember, from my properties of logs, when I have an exponent inside a natural log, I can bring that exponent down here in front. Okay, now I've gotten the exponent down. Okay. Okay. Now, here's the thing I'm going to do here. Is I don't really have a fraction here, but I'd like to have a fraction so I can use LHopitals Rule. So I want to put this over 1. And that doesn't really help me a whole lot, but it does let me do this. The natural log of y. And you know what? Always a lot of mathematicians will just, and your book does this, they put the natural log of y here, and then they just leave this side blank, okay? And I don't like to do that because the last step is I need to get rid of that natural log, and if I leave that up there, I always forget to do that, and you'll just kind of see what happens here. Okay, so here's what I'm going to do is I'd really like to have something at the bottom, so I'm going to divide the top and bottom of this by x. Okay, if I do that, cancels this x out and just leaves me with natural log of 1 plus 1 over x, and it gives me 1 over x on the bottom. Okay, now I've got something I can use LHopitals Rule on. Okay, so remember this is okay, so what's the derivative of this? Well, it's 1 over this stuff. And then times the derivative of this. So this is the derivative of 1 is 0. The derivative of x to the negative 1, which is what that is going to be negative 1/2 x to the negative 2. No, hang on. Sorry, I always have to do these. That's going to be oh no, it's just negative 1. Sorry, I'm trying to integrate in my head. So it's not 2, not 1/2 here. Okay. And then this is going to be over, again, this is x to the negative 1, so this is negative x to the negative 2 power right here. Okay. Now, that's going to cancel that. So this is going to be the natural log of y is going to be the limit as x goes to infinity of 1 over 1 plus 1 over x. Okay, that I can do because the natural log of y, this is going to be 1 over 1 plus 0. So this is just going to end up being 1. Now, here's why I like to bring those natural log of y's down, okay? Because what a lot of people do is they leave the first natural log up there, and then they leave the rest of these blank, and they get down here, and they go, oh, 1 is the answer, done. But remember, we don't want to know what the natural log of y is. We want to know what y is. So what we need to do is we need to take e to both sides to cancel out that natural log right there, and I get y equals e to the first power, which is just e. The limit is e. Okay, so do things, I mean, it's a little more work. You got to write a little bit more, but who cares as long as you get the answer right, right? Okay, here's another one with an exponent. So what are we going to do? We're going to go ahead and use the natural log again. Okay, so the natural log of y is going to equal the natural log of the limit as x goes to 0 from the positive side of sine x to the x power, like that. And then the next thing I'm going to do is I'm going to move the natural log inside the limit. So this is the limit as x goes to 0 from the positive side of the natural log. Whoops, hang on. The reason I'm doing this is so I can put the x down here, natural log of sine x. Okay, then I can do the same technique that I did before, okay, where I take this and I make this a fraction and then I divide it by x on top and bottom. So the natural log of y is going to be the limit as x goes to 0 from the positive side. Let's get rid of this stray dot right here. Okay. And then this is going to be the natural log of the sine of x over 1 over x. Okay. Now I've got a fraction here. I've got no exponents. I'm taking a limit. I can't do it because if I plug in 0 here, I get the natural log of 0, which I can't do. And if I plug 0 in here, I get infinity, so I can't do that. Okay, so let's try taking the derivative. Now, this is where it's really handy to remember your trig formulas. So the derivative of this is cotangent of x. That's one of those ones nobody remembers. Okay. And this ends up being negative 1 over x squared, just like it was the last time. Now, here's a trick that a lot of people don't think about, but it's pretty simple. Okay. So this is essentially 1 over tangent divided by negative 1 over x squared. And remember, when you divide fractions, you invert and multiply, right? And so this ends up being negative x squared over the tangent of x. Okay, I still can't do that because if I put in 0, I get 0 and over 0. So let's take the derivative again. It's exciting stuff, isn't it? So the natural log of y would be the limit as x goes to 0 from the positive side of negative 2x over, let's see, the derivative of tangent is secant squared. Okay, can I do this? Well, if I plug in 0 here, I get 0 on the top, so that's a problem, maybe. If I plug in 0 here, secant squared of 0 is 1. Oh, okay. So I got a limit finally. And the limit, or the natural log of y, is going to equal the limit of this. That's going to be 1. I'm sorry, it's going to be 0. Okay, now don't forget, we still have to get rid of this natural log, so we're going to take e to both sides. Okay, and that's going to go away, and I get y equals e to the 0 is 1. Woohoo! So that wasn't too bad. Okay, what about something nasty like this? So if I plug in 1 here, I get 1 over 0 minus 1 over 0. So that's basically infinity minus infinity. Doesn't really tell me much. Okay, what do I have to do here? Well, I need to combine this into one thing. So I'm going to get a common denominator. So here's what I'm going to do. I'm going to take the limit as x goes to 1 from the positive side. I'm going to multiply this side here by x minus 1 over x minus 1. So that's going to be 1 over natural log of x. And then over here, I'm going to multiply 1 over x minus 1 times natural log of x over natural log of x. And that's going to give me a common denominator. So my limit as x goes to 1 from the positive side, this is going to be a fraction where I've got natural log of x times x minus 1 on the bottom. Here I'm going to have x minus 1 minus the natural log of x. Okay, so if I plug in 1, I get 0 minus 0, so it's 0 on the top, and then I get 0 times whatever, 0. So I still have an indeterminate form. So I need to take the derivative of this thing. Oops. So this is going to be the limit as x goes to 1 from the positive side. Okay, derivative of x is 1, derivative of negative 1 is 0. Derivative of 1 over, or natural log of x is 1 over x. Okay, and then this is going to be the product rule on the bottom. So it's going to be the derivative of natural log of x is 1 over x times x minus 1 plus natural log of x times the derivative of x minus 1, which is just 1. Okay, so what does this come out to be? Let's clean this up a bit. This is going to be the limit as x goes to 1 from the positive side. No problems on the top here. All right, 1 over x times x is 1 minus 1 over x plus natural log of x. Okay, still a problem. This is 0 on the top. This is 0 on the bottom. So I'm going to need, what happened? Nothing. Okay. I'm going to take the derivative. The limit as x goes to 1 from the positive side. So that's 0. X to the negative 1 ends up being, negative 1 over x ends up being 1 over x squared on the top. The bottom, that's 0. That's 1 over x squared plus 1 over x. Okay, now what happens if I plug in 1 here? All right, if I plug in 1 at the top, I get 1 here, and I get 1 here. Hey, that's 1 over 2. There's my limit, 1/2. So this isn't too bad. A little bit of algebra involved. Lots of derivatives of natural logs and stuff, but you should be able to handle that. So here is your assignment. It's your last homework assignment of the year. How exciting. Okay, so have fun with that, and I will see you next time.